Unit 6, Target 3 is power of a power. Power of a power is when you have a power that is raised to another power. So the power of a to the m raised to the n power. To simplify this, the base stays the same and you multiply the exponents. So the base stays the same and you multiply the exponents together. So if we have 2 to the second power raised to the third power, you notice we have a power raised to another power. You simply multiply the exponents. The base stays the same, and you multiply the exponents together. So your answer would be 2 to the sixth power. You can either expand or leave your answer as a power. Now the reason why this works is because remember that the exponent tells you how many times your base is a factor. So 2 squared raised to the third power means 2 squared times 2 squared times 2 squared. Now if you remember, when you're multiplying powers, you add the exponents. So 2 to the 2 plus 2 plus 2, which is the same answer, 2 to the sixth power. You could even expand further, because 2 squared means 2 times 2 times 2 times 2 times 2 times 2. That would be 2 to the 1, 2, 3, 4, 5, 6 power. You get the same thing. So instead of expanding it like this, you can simply just multiply the exponents together, and you get the same answer. So here's one using a variable. The base stays the same. Multiply the exponents together. Power of a power. X raised to the 33rd power, and that would be your final answer. Okay, negative exponents are no different. The only thing is that if you have a negative exponent in your answer, you need to simplify that. So this would be y to the negative 2 times 4, which is y to the negative 8. Remember that negative exponent means reciprocal of x to the 8th power. So that would be 1 over x to the 8th power. Make sure you leave your answers with positive exponents. Okay, here's your lesson check. Your lesson check for example 1. Make sure you write this answer down so that you can enter it into the lesson check. When a power is raised to the power, the base stays the same. What do you do with the exponents? Okay, now we're going to talk about power of a product, and that's when you're raising 2 or more terms together raised to a power. Now, when you are raising a product to a power, apply the exponent to both factors of that power. We're still multiplying. We just have to make sure it goes to both factors, a and b. So you'd have a to the mn, b to the mn. You notice that these bases are different, so you cannot combine them into one term, so that would be your answer. So here, since 2 and 3 are different, we cannot combine them, but we do have to apply the exponents to both factors. So you'd have 2 to the 4 times 2, 3 to the 3 times 2 power, so that would be 2 to the 8th times 3 to the 6th. And that's your final answer. You could expand if you want to, but you don't need to. Okay. Oh, we went backwards. Hold on. Okay. So here's a couple examples that we're going to look at. They have some coefficients involved. So if we're looking here, we have 3x squared, y to the 4th, being raised to the 5th power. Now, if you look here, there are 3 different factors. So we have to multiply the powers together of all 3. Now, the number 3, that coefficient, does not have an exponent listed, so the exponent is 1. So you'll multiply 3 to the 1 power times 5, x to the 2 times 5, y to the 4 times 5. So your answer would be 3 to the 5th, x to the 10th, and y to the 20th. Now, because 3, x, and y are all different bases, you cannot multiply them together. You could expand this, and on your homework you may see that, but you can do that on your calculator, 3 to the 5th power. Which, so you can check, is 243. So that would be 243 x to the 10th, y to the 20th. So you just need to be able to recognize that in your homework. Okay, this one, let's do that again. We have 3 factors that we have to multiply the powers to. This is the same as 2 to the 1st power. So that would be 2 to the 1 times 3, x to the negative 3 times 3, y to the 2 times 3. So we're going to get 2 to the 3rd, which is 8, x to the negative 9, y to the 6th power. Now, since this is all over 1, anything with a negative exponent has to change to the bottom. If it was in the bottom, you'd change it to the top. So on the top, 2 to the 3rd is 8, y to the 6th. Those both have positive exponents, so they're going to stay in the numerator. And then x to the 9th will come down in the denominator to be positive. So your answer is 8y to the 6th power all over x to the 9th. Okay, let's practice a couple more examples. Okay, this first one, negative 3, x to the negative 4th, y to the negative 2nd, and that's all squared. Now, since your negative 3 is in parentheses, you're going to have to keep it in parentheses. So that would be times 1 times 2 power, or we just say squared, times x to the negative 4 times 2, y to the negative 4. So that would be negative 3 squared. Negative 3 times negative 3 is a positive 9. Then you have x to the negative 8, y to the negative 4. Okay, anything with negative exponents has to change. These negative exponents are in the numerator, so they have to move to the denominator. 9 does not have a negative exponent, so it's going to stay. And then you'll have x to the 8th power, y to the 4th power. And then that's your final answer. Okay, let's look at this other example here. You will have 5 to the negative 2, x to the negative 14, y to the negative 8. Now, all 3 of them have negative exponents, so they're all going to move to the denominator. So you'd have 5 squared, x to the 14th, y to the 8th, which would be 25x to the 14th, y to the 8th power. Okay, example number 2. Go ahead and write this down and then be ready with your answer for the lesson check. You have 3x to the 5th, y to the negative 3, all raised to the negative 2nd power. If you need to pause to write that down and simplify, go ahead and do that and be ready to enter your answer into the lesson check. Power of a quotient. Okay, this is, instead of a product in the parentheses being raised to a power, you have a quotient. Quotient just means divide. When raising a quotient, a fraction, to a power, apply the exponent to the numerator and the denominator. Let's fix that. 2 power. When raising a quotient, a fraction, to a power, apply the exponent to the numerator and the denominator. Okay, so if we have a to the m divided by b to the m power raised to the m power, you'll have a distribute to both, so n power over b to the m times n power. Okay, a, since they have different bases, you cannot combine those into one term, so that would be your final answer. So here we have hold on. So x squared divided by y to the third power, all raised to the fourth power. That means you're going to have x squared times 4, but you also have 3 to the y to the third times 4. So that's x to the 8th divided by y to the 12th. Since x and y are different bases, you cannot combine them, and that is your final answer. Okay, let's work through a couple more examples. And then we'll have one more lesson check question, and then you'll be ready to do your homework. Okay, we have a couple with coefficients, one with coefficients, and we have some negative exponents. So let's see what that looks like. You have x to the negative 6th raised to the second power, so that would be x to the negative 12, because negative 6 times 2 is negative 12. And then you have y to the 5th raised to the second power, so that would be y to the 10th. Make sure you multiply. Now, because x to the negative 12th, you have a negative exponent, you have to move that to the bottom. So you would have x squared to the 12th power, y to the 10th. Now, there's nothing left on top. You have to make sure those stay in the denominator, so what's left is 1. So if everything's moved from the bottom or the top, that means that it leaves a 1. Okay, let's try this last one. Here we have a product and we have a quotient all together. So we have two things going on here. So we're going to apply the exponent to both the 4 and the x squared. So that would be 4 to the negative 3, x to the negative 6, all over. Apply the 3 to the denominator as well, which will be y to the 9th power. Because negative 3 times negative 3 is positive 9. I do not know why those did that. Okay, now we have some negative exponents. This is going to have to move to the denominator, and so is x to the negative 6. Since there's nothing left on the top, and we know that 1 is left on the top, so that would be 4 to the 3rd, x to the 6th. Now, y has a positive exponent, so it's going to stay where it's at. So your final answer would be 1 over 64, because 4 to the 3rd power is 64, x to the 6th, y to the 9th. Okay, here's your last lesson check. If you need to review those, just go ahead and rewind and watch through those again. Here's your last example. Please write your answer down so that you can enter it into your lesson check. You have 2x to the negative 5th divided by y to the negative 2 power, all raised to the negative 3rd power.